Good afternoon, guys. Again, welcome back to Trigonometry. Time goes fast, right? So this is the last video, okay? Unless if I have time, I will be making another video about how to solve more trigonometry equation, or we're doing more practice on vector concept. However, if I don't have time, then this is the last video, okay? And we're almost done, guys. We have only test number 3 and the final exam, and that's it. I have to say this, we already cover like 95 to 98% of the curriculum of the course required. There's just a little bit more we couldn't cover because you guys know that we've been falling behind about a week because of the virus. So, but I don't think that concept is really important. To those who's gonna take calculus 1, calculus 2, and calculus 3, you won't see that until maybe calculus 3, maybe. So I don't think that's really important at this time. I want to stop after this video because I want you guys to spend more time doing research on the test number 3 and the final exam. That's the most important thing, and I will use the result of test number 3 and final exam to determine if you eligible to pass the course or not. So far I see that most of you did very well, and I'm happy with that. However, some of you still been falling behind because you guys didn't do homework. I see a few students, you guys didn't do any homework so far, so that's maybe the reason of the bad grade. As I say, this is the last video, and we have to continue, and hopefully after this video, so far I have not received any question after this video. Then I received like 2 or 3 questions only. So after this video, you guys have more time to ask me question. Okay. So in the previous video, we talked about how to add subtract integer, right? Add and subtract vector, I'm sorry. How to multiply a vector by the number, as we know that when we add or subtract 2 vectors, they give you another vector. If you multiply a vector by a number, it also gives you another vector. The question is, what if I want to multiply 2 vectors together? What's going to happen? Is it going to give you a number as a scalar quantity, or it give you another vector? Okay, as you add or subtract or you multiply a number by the vector, give you another vector, right? So that is the question we need to answer for this lecture. Okay, and when you multiply 2 vectors, the multiplication of 2 vectors, we call the product of 2 vectors, and that product we call it the dot product. Okay, the reason we call it dot product because we want to tell the difference between the dot product and the cross product. The cross product of 2 vectors, you guys are gonna learn that in calculus 3. But today we're going to talk about dot product between 2 vectors. Okay. It's just nothing. It's just the multiplication between 2 vectors. You know, dot product. Okay, and there are 2 methods of defining dot product. Okay, so first of all, definition. Okay, there's 2 methods to define dot product. The first method, okay, the first method is we're going to use the coordinate of 2 vectors. Using coordinate 2 vector. Okay. Just say I have 2 vector u and v, right? And vector u we have coordinate is u1, u2. Okay. And vector v we have the coordinate is v1, v2. Okay. And I want to multiply these two vectors together, vector u times vector v. Okay. To give you, this one is a dot product. Well, the reason they call it dot product because it's just a dot over there, you know. And the dot is actually multiplication sign, right? So the dot product is nothing else but just multiplication between two vectors. And when you multiply two vectors, okay, the answer is to get a number. The answer is a number. It's not a vector anymore. Okay. So when you multiply the dot product, when you multiply two vectors together, okay, it gives you a scalar quantity. Remember that. So how we do that? So in order to get the dot product between vector u and vector v, you're gonna use this coordinate of vector u and vector v. So this is give you u1 v1 plus u2 v2. See, u1 v1 u2 v2 is actually a number, right? And when you multiply that, it give you, and you add it, it give you a number. So dot product. I want to put a remark here. Dot product of two vectors is a scalar quantity. Now you can answer that question I give you before, right? So it's different from adding or subtracting or you multiply a vector by a number. The dot product gives you a scalar quantity. When you add, however, when you add, you subtract or you multiply a vector by a number, it gives you a vector quantity. A dot product gives you a scalar quantity. It means a number. Okay. For example, I have vector u. Coordinate is, for example, 1, 2, right? And vector v have coordinate is 3, 4. Then the dot product between these two vectors is u1 times v1, so 1 times 3 plus 2 times 4, which is 4, 8, give you 12. There you go. So yeah, it'll give you a number. A scalar quantity. It's not a vector. Okay, does that make sense? A second way of defining dot product between two vectors is to use the angle, using angle created by two vectors, and using the magnitude of those two vectors. Okay. So the dot product of u and v, again, the dot product of u and v, instead of using the coordinate, it can be defined as follows. This u times v equal to the magnitude of u times the magnitude of v times cosine the angle between vector u and vector v. So cosine, the angle, you take cosine of that angle, then you multiply the magnitude of u, multiply by the magnitude of v, then the answer is give you the same scalar quantity as the expression give you. Okay, so there's two methods to define. However, in this method, to define the dot product, you see that in order to find the dot product, you need to know the vector of u, you need to know the coordinate of u, you need to know the coordinate of v, however, you need to know the angle created by those two vectors. If you don't know the angle, then you cannot use this formula. Okay, you cannot use this definition to get the dot product. Okay. So if you compare between two definitions of dot product, you will see that the first definition seems to be more convenient, right? Because for this definition, you need to know the angle between two vectors. If you don't know the angle, then you cannot define the dot product. Okay, so then using these two definitions here of the dot product, we can deduce some property which is very important, and this property it helps you to prove a lot of things. Okay, of course, again we're not going to do the proof in this course, but you need to know this property also. It's very important later on. So in the second part of the lecture, we're going to talk about dot product property. Okay. The first property is if you multiply a vector by itself, the vector u times vector u, okay, and it gives you the magnitude of the vector u squared. Okay, this property I see many times in calculus 3, and I see many times in another level of math called linear algebra. If you guys major in computer science, you have to take linear algebra. Then you see that many times. The second property, okay, it is commutative. So if you have u times v, dot product between u and v is the same as dot product of v and u. So this commutative property. We also have associative. If we multiply vector u by the sum of vector v and vector w, then this is distributive, I'm sorry. Then you can distribute it, u times v plus u times w. So this is distributive. Okay. Okay. We don't have associative, I'm sorry guys. However, we have something like this. Also, if we multiply a k value by the dot product u and v, then it can give you k u, okay, dot product with vector v, okay. It could be u times k vector v, okay. All right. So that's the fourth important property I want to introduce. Okay. In this course, you see that you don't have to use many properties here, but according to the curriculum, you guys still have to learn it. Just pay attention to the first property. You might have to use it on the final exam. Okay. Other than that, you just need to scan over, but you don't need to pay attention too much. But it's good, of course. You have to memorize it. Okay. But this is a final exam. You know, this is a take-home final exam, take-home test 3, so you don't have to worry about it, right? Alright. So, okay. Next, I want to ask you this. In this second way of defining dot property between vector u and vector v, you see there's an angle, right? And you have the cosine here, right? And I want to ask you, what if I let, okay, what if I let cosine, okay, I let cosine of vector u and vector v equal to 0. Okay. if cosine of vector u and vector v equal to 0, right? So this everything here is 0. Okay? Everything here is 0. Okay? The whole thing here, right here is 0. Anyone can tell me what will be the angle created by vector u and vector v such that when you take cosine give you 0? What angle? How many degree? How many degree of the angle between vector u and vector v such that when you take cosine it gives you 0? Okay, think about a unit circle. It's at 90 degree, right? 90 degree. Or 270, right? Alright. So, if the cosine of u and v equals 0, it means the angle between vector u and vector v, okay, this is mean angle, is 90 degree. Okay? If the angle between vector u and vector v, just think about it, if the angle between vector u and vector v is 90 degree, okay, then vector u and vector v is perpendicular to each other, right? Because 90 degree. Okay. So I mean vector u is perpendicular to, this is perpendicular symbol, vector v, right? And perpendicularity in vector analysis we call orthogonality. So in the third part of our lecture, I want to talk about orthogonality. Okay? Between two vectors. Okay? Orthogonality. Orthogonality means perpendicularity. Okay? It means vector u, geometrically, you have vector u like this, and you will have vector v like that. 90 degree here. Or you have vector u like this, and you have the vector v like that. It still creates 90 degree there. Okay? So it's perpendicular to each other. So if the angle 90 degree, it gives you cosine 0. And if it cosine 0, you have u times v equals 0. Right? We got a 0 here, the whole thing is 0. It means u times v. It means u times v. 2 times v equals 0. Ah, so what do we know about this? It means that when you have two vectors perpendicular to each other or orthogonal to each other, the dot product is 0. That's what it means. Okay? So let me put a remark here. Put a remark here. Remark. Okay. U perpendicular to V, then is equivalent to U, the dot product of U and V equals 0. When I say perpendicular, when I say equivalence, when I use this sign, it means that if you have this, it implies this, okay? And if you have the left-hand side statement, it implies the right-hand side statement, okay? It means perpendicularity or orthogonality, the same meaning, okay? Okay, let me give you an example. Let me see if I can find an example here now. Let me see. Okay. Okay, so example. I give you two vectors. U is 3, -2, Okay, and vector v is for 6. Okay, and the question the question is to show these two vectors perpendicular to each other now. Okay, show that u is orthogonal to v. Okay, solution. Easy, right? In order to show two vectors orthogonal to each other, you need to show the dot product equal to 0. You need to show the dot product equal to 0. So you just need to find the dot product between u and v. So u and v, the dot product will be this times this, 3 times 4, according to the first definition. Okay, plus 6 negative 2 times 6. So give you 12 minus 12. Here you go, it's 0. And if it is 0, then it's orthogonal to each other. Okay? Very simple example. And with the second definition of the dot product, you see that we can also find the angle between two vectors. Okay, you can find the angle between two vectors easily if we know the dot product and we know the property, we know the magnitude, right? So from here, so I'm going to put another remark here. So this is remark, I think the first one, we already had one remark already, right? So this is the second remark and this is the third remark. Okay. So from the second definition of the dot product, I can find the angle using this formula. Cosine of vector u and vector v is equal to u dot v over this, right? There you go. So if the question asks you to find the angle between two vectors, you're going to use this formula. Okay. Alright, very good. As for the last part of lecture, I want to talk about in my opinion, I consider that as application of the dot product because you use this concept a lot in physics. That's my opinion anyway. The concept is called a scalar component. A scalar component. Scalar components of a vector on another vector. Scalar component. Well, actually, I hate this name. I don't like this name because it's a scalar component of the vector. Because actually, a vector itself, when you find the magnitude, it has component already, right? And what it means over here is that they want to make a projection of that vector on another vector. Okay, this is what I mean. Let me draw the vector u. Vector u here. Let me give you vector v here. I'm sorry. This is vector v. Okay. And I have another vector. I have a vector v that looks like this. this is vector v, I have vector u, I'm sorry, this is u here, this is v. And I want to find the scalar component of vector u on vector v. Question? Find scalar component of vector u on v. It means that you find the magnitude of projection of vector u on v. That's what it means. That's what it means. So what do you mean by projection? Just think about this. I have vector v like that. Okay, I have the vector v like this. And I have vector u like this. The projection of vector u on vector v is the way you look. It's the shadow. It's not a shadow, it's the image. I'm sorry, I have to use the right term. It's the image of this vector when you look from the top. Okay, so if I look from the top, I see that the image of this vector here is on the side of vector v here. Okay, so if I look at on the top, I see that the image is like that. Okay, so that image is shadow is right here. So the image of the vector is a vector, right? Okay, it's like you have a vector and the shadow of that, okay, is another vector here, okay? And the scalar component is actually just the magnitude of this, okay? You just need to find the magnitude of this. That's what it means, okay? So this is right here a projection of u on v. Okay, projection. So how we do that? There are two methods. Method 1. For this method, we use the following formula. Okay, the formula is like this. If I call theta is the angle between u and v, between vector u and vector v, then the scalar component, we notate it as comp, okay, of u on v, okay, of u on v is equal to the magnitude of u, okay, times cosine theta. Okay. So that's this formula to calculate the scalar component of u on v. Actually, this formula is derived from the fact that if you translate, you see the red vector over here in red color here, if I translate that vector, if I translate this vector here to this position, okay, so the red vector over here in red color here become this one, and the angle theta between u and v is this angle, okay, and you see that this is the right triangle, then you if you want to find, then this is adjacent, right? This is adjacent. This is opposite. This is hypotenuse. So in order to find the adjacent, you take cosine, right? Cosine of theta equal to adjacent. Okay, this is adjacent. Okay, this is hypotenuse. Adjacent over hypotenuse. And hypotenuse is vector u, right? The magnitude. Okay, adjacent is adjacent is the COM. The adjacent is COMPUV. Okay, adjacent is actually the red vector translated to this one. Okay, this is COMPV. Okay, so this is COMPUV. Alright. So this formula here is actually come from that fact. We translate the vector in red color to become the adjacent side of this triangle there. Okay. Now I want you to take a look at this one also. If we use that formula, okay, and I replace cosine theta. Remember in the remember the second definition of the dot product. What we have? We have u times v, right, equal to what? Equal to magnitude of u, okay, times magnitude of v, right? So I say we have times cosine theta, right? And if I replace, then over here we can obtain the cosine theta, right? If cosine theta is theta between u and v. It's u times v over u magnitude, v magnitude. And if I replace the cosine theta here with this one, then I can obtain the second method, method 2, to get COPV, C component, scalar component of u on v become what? Magnitude of u, right? Time cosine is this, right? So cosine is u times v over u times v, right? Magnitude, right? See? If I replace this with that, then scalar component become u. I replace that, I plug over here, then I cancel the u. Then my scalar component of u on v become what? Become magnitude, the vector u over time vector v over magnitude of vector v. Okay, that's the second formula. Okay, so you can use, actually the second formula is derived from the first formula, and the first formula derived from the fact that we translate the red color vector to become the adjacent of the triangle here. Okay? Okay, the triangle here. Alright. That's all. So that's the method to find the scalar component of a vector on another vector. You use this a lot when you have physics, first course, second course of general physics. Okay? I can give you an example really quick. It's very easy, guys. It's nothing hard. Okay, example. So I have two vector u is 2, 3. Okay. And v is 4, 1. I want to find scalar component COM of u on v. U on v. Okay. This is mean u on v. Okay. Alright, let's see which one we can do. We can use the first method or the second method. Over here, it will give us the angle between u and v. Then I think I'm going to use the second method. That's easier, right? Solution. Alright, in order to find the second method, we need to find the dot product. Easy, we can find the dot product right easily. We using the first definition using the coordinates. So 2 times 4 plus 3 times 1, 8, 3, 11. Alright. Then you find the magnitude of v. Okay, magnitude of v is using Pythagorean theorem. 16, right? Plus 1, 4 square, 1 square. Okay, equals 17. Alright, then you can find the scalar component easily. COMP u on v is equal to u times v is 11 over square root of 7. And that's it. Alright. Very easy. Okay. Alright, so that's all. That is the end for the lecture, and it's the end of this semester. As I told you at the beginning of this lecture, if I have time, I will make another video doing more practice, so that you can get used to, and so that you can be exposed to more different type of question. However, if I don't have it, then that's all for the semester. That's all. All right. If you guys have any question, let me know. Just put your question on the discussion board. The reason I want to stop over here, I already told you that because I want you guys to focus on test number 3 and the final exam. I want you to have more time to study. I want you to spend more time on doing home. Okay. Doing more concept is not really important because we have covered 95 to 98% of the curriculum already, which is very good. Okay, especially in this situation when the virus spreading and we've been falling behind 2 weeks. So yeah, so don't hesitate asking questions. And make sure that you guys contact each other, be on the phone, be in touch, you know, okay. I know you guys could not meet each other, but be on the phone, call each other, get help from each other. And you can get help, as I told you, we can get help from Valencia tutoring service online on campus, right? I will show you the video, how to get it. Okay, so that's all. And yes, if we have a chance, we can meet each other again next semester or maybe in fall. Alright, I'll see you next time. Bye bye.